Okay. So in our previous class, we were discussing about the revision. We are doing revision of the water chapter, and we have stopped in the previous class at this point, which are the different properties of the water, the of the chemicals. Okay, efflorescent, deliquescent, hygroscopic, desiccant, and dehydrating substances. The question was that if you are trying to package an electronic item, so which kind of the substance would you choose to protect it from the excess moisture? So you have got my question. So mostly you will be seeing that in certain packagings, you will see that there is a small pouch. Okay, so in that pouch there will be some kind of beads. So if you read the label, it will be written as a silica bead, for example.
Silica.
Silica beads. So the question here is that which kind of substance would you prefer to use for this kind of packaging? Would you use an efflorescent, deliquescent, hygroscopic, desiccating, or dehydrating substance? Okay. So for that, first we should know what is the efflorescent. Okay, you should revise efflorescent. Efflorescent substance means on exposure to air, it is going to lose its moisture, its water of crystallization. So here we will write minus water of crystallization. Okay. That is what is taking place in efflorescence. And for example, if we heat or expose this washing soda, okay, washing soda is sodium carbonate, okay, in the hydrated form, that is decahydrate. This is the washing soda. So washing soda is the one that you would use in the detergents. Okay, in the washing soda we will use in the detergents. So this washing soda, if it is left exposed to the air, then what will happen? It will lose the water of crystallization and it will become a monohydrate. Okay, monohydrate. 9 waters of crystallization it is going to lose. So this process in which it is losing this water of crystallization on exposure to dry air is the
There
efflorescent
is the
substance. Okay. Deliquescent, on exposure to the moisture, okay, from the air itself. Okay, you know, hot and humid climate or like that is there. So when there is a lot of moisture in the air, it will absorb that moisture. It will lose its crystalline form. Okay, not water of crystallization. It is going to lose its crystallization form and it will become a saturated solution. So for example, sometimes you would see, if you are visiting at home or even outside also, just they will give some extra salt in some cup or something. You know, you go to some restaurant or anything and you open that and then you see that the salt is all wet and all, you know, as if someone has put water in that one. So what is happening is some substances they can absorb the moisture, but After absorbing the moisture, it should become a saturated solution. That is important. Okay, it should become a solution. It is not sufficient just it is absorbing the moisture. That is not sufficient. So if minus crystal form, okay, absorb atmospheric moisture, okay, and what it has to become, it has to become a saturated solution. Okay, it has to become a saturated solution. So example here is, for example, sodium hydroxide pellets. Okay, in the laboratory you will see that sodium hydroxide, potassium hydroxide, these are available in the form of pellets, that is rounded like button shape it will be there. But if you leave that in the open, after a few hours you will see that it has become totally like water. Okay, so what it has done, it has lost, because the sodium hydroxide, it has lost its crystal form, it has absorbed the water and becoming a saturated solution, that is a deliquescent. Hygroscopic. Hygroscopic means it will absorb the moisture, but it will not become a saturated solution. Okay, absorb atmospheric moisture. Okay, but it is not sufficient to become a saturated solution. So example would be, say, quicklime, silica gel, phosphorus pentoxide, concentrated sulfuric acid. Okay. All of these are hygroscopic. Now the question is, what is a desiccant? Desiccant or dehydrating agent or drying agent? Drying agent. So what will be the difference between hygroscopic and dehydrating agent or desiccant?
The hygroscopic substances absorb moisture to form the saturated solution, whereas the drying agent absorb
Not form saturated solution.
yes, sir. So hygroscopic absorbs atmospheric moisture to form the solutions, whereas the drying agent absorbs moisture from the other substances.
Okay, here I think little bit more clarity is required. It will not form a saturated solution or unsaturated solution. It won't form solution at all. Okay, so maybe for it's better for me to remove this saturated solution altogether. Okay, let me just write solution. It will not form a solution. No solution. Whatever it may be, saturated, unsaturated, it will not form a solution. Just it will absorb the moisture and it will be in a solid state with a little bit of moisture in that one. That way it will look. But you cannot say it is a solution, because solution means what? It should be clear, transparent. Okay, the light should be able to pass through it. There should be no scattering effect. All those things are, then only we can say solution. No, so whether it is saturated or unsaturated super, no solution will not form. Okay, there is no solution formation. It will absorb the moisture. That's all. The desiccating agent, it will also absorb the moisture. Okay, it is nothing but a hygroscopic substance. Okay, can we can you like tell exact what will be different hygroscopic and desiccating? Both are going to absorb moisture. This also drying agent is going to absorb moisture. Yes, it is going to absorb the moisture.
Sir,
Hmm.
Sir, I think that hygroscopic substance chemically react with the substance means chemically react with the other substance, and deliquescent substance or that drying agents do not react with the other substance. Chemically react with others.
Yes. See here, both are nothing but the same. Okay. The desiccating or drying agent and hygroscopic substance. Okay, they are the same. When you are using a hygroscopic substance for the purpose of drying purpose, then we say it is a drying agent, desiccating substance, desiccating agent. Okay, but this desiccating or drying agent is nothing but hygroscopic substance itself. Therefore, we will not consider this as a totally separate. Okay, here a hygroscopic is a property, no, hygroscopic substance, it is showing hygroscopy, it is a hygroscopic substance. Okay, but depending upon its usage, okay, if it is used for the purpose of drying or desiccating, it is a desiccating or drying agent. Okay, but it is what, it is nothing but the hygroscopic substance itself. So whatever examples you are putting in hygroscopic, most of them will be example as a drying agent or desiccating agent. Okay, so can in a hygroscopic substance, both solid and liquid are there, or only solid is there?
Only
Sir,
solid.
hygroscopic solid.
Both are there. Okay, both are there,
Yes,
they
sir.
can be,
Absorb moisture from.
yeah, both solid and liquid. Liquid hygroscopic substance is concentrated H2SO4. Okay, H2SO4 is example of that liquid hygroscopic substance. It will take up the moisture. It is so much high property of absorbing this moisture. We are using it as a dehydrating agent. Okay, we are using it as a dehydrating agent. Dehydrating agent is a removing of water. Even from the chemical substance, it is able to remove water. For example, blue vitriol is there. From that, if you add the concentrated H2SO4, then it will remove that water of hydration from the blue vitriol. Okay. Similarly, in the making of the sugar charcoal, sugar cane sugar, the cane sugar is treated with concentrated H2SO4. Okay, so C6H12O6 is the formula for glucose, but for sucrose it will be C12H22O11. Okay, this is the sucrose, that is nothing but the table sugar that we are using. If you will treat it with sulfuric acid, a dehydrating agent, it will remove all the chemically bound water from this one H2O. Can you see this? It's almost like H2O formula, no? H22O11. Okay, just divide it by 11 and you will get H2O. Okay, so 12 carbons and 11 H2O, 11 H2O will come. Dehydrating, it is removing. So the liquid form hygroscopic is concentrated H2SO4. It can be used as a dehydrating agent. Some of these hygroscopic substances can be used in packaging material like silica gel. It is a solid. Okay, it will not completely convert into liquid. Okay, and form solution, so it is safe. Otherwise, if it become completely liquid, what is the fun? Again, it will damage the electronic item. Okay, whatever packaging material is there. So, for a desiccating agent or drying agent, we are using the certain hygroscopic substances like the silica gel or anhydrous calcium chloride, anhydrous zinc chloride, phosphorus pentoxide. All these things can be used. Okay, it is clear. Okay. If there are no doubts, then we will go to the next section. Hard water and soft water, we can revise. Hard water, soft water. So when we say that water is soft water, is there any way we can say it is soft water? Or we say it is hard water. Someone wants to give?
Sir, water is said to be soft. It readily forms lather with soap.
Yes. So when we are using the soap, quality of water is very good. Okay, sir. In Hindi we say meetha pani, no? That is the sweet water. So the sweet water in English we would say is a soft water. Okay. Here this soft water does not have too many minerals. Okay. It has comparatively very less minerals, sufficient amount of minerals, but very less minerals. So when this kind of water we are using with the soap, then with very less amount of soap also you get a lot of lather. That is the foam. Lot of foam you will get. But if you use a hard water, the hard water has a lot of salts. These salts will not allow to form that much good amount of foam or lather with the soap. We say it is the hard water. Now, what is the reason for the hardness of water? Two things are there. Okay. One is the carbonate, one is the non-carbonate. Okay. Because we say no, some salts are there. So what type of salts? It may be carbonate salts or non-carbonate salts. Carbonate salts means it includes both carbonates and bicarbonates. Carbonates and bicarbonates. Okay. Under non-carbonates, we have the chlorides and sulfates. Okay. Generally, the metal part here is calcium and magnesium. Calcium and magnesium, carbonate, bicarbonate, chlorides, sulfates. Okay, this way. So, what is the difference? For example, calcium carbonate, calcium bicarbonate. Can you tell anything about the solubility? Is calcium carbonate soluble in water?
No, sir, it is insoluble.
Insoluble, correct? So, we say it is a precipitate. And what about calcium bicarbonate?
Sir, it is soluble.
Soluble. Okay. This is the important property that you need to remember. Calcium carbonate insoluble in water, calcium bicarbonate soluble. Okay. So, if the water has the bicarbonate, calcium bicarbonate or magnesium bicarbonate, then it gives the temporary hardness. Okay, we say temporary hardness. Why? Because this is soluble. No, calcium bicarbonate is soluble. If you boil it, okay, you boil, then what is going to happen? This bicarbonate will be converted into carbonate and it will precipitate. Okay, so when we are boiling water, if it is the temporary hardness, this calcium or magnesium bicarbonate is there, then we will see that white salt will deposit in that vessel. So the bicarbonate is converted into the carbonate form. The carbonate form will precipitate out. So in this way, it can be removed easily. This kind of hardness we say temporary hardness. Okay. Okay. Suppose it is the non-carbonates are there. The non-carbonates, for example, calcium sulfate. Calcium sulfate. If these kind of things are there, then it will result in what we say permanent hardness. Okay. Permanent hardness means what? Simple
That cannot
boiling.
be removed by boiling.
Simply if you boil, that will not remove this one. You need to do some specific chemical treatments. Okay. So this temporary hardness can also be removed by chemical treatment. Okay, depending upon how much we cannot boil thousands of liters of water for supply purpose or anything like that. So under those conditions, we will go for chemical treatment. But the simple at home for some time only people want to use emergency purposes, they can boil and remove the temporary hardness. Now, if you want to remove this permanent hardness, then you have to treat it with what soda? Washing soda.
Soda ash.
So what is the difference between soda ash and washing soda? Can we call this as the washing soda?
Yes, sir.
We cannot call. Hydration should be there. Decahydrated 10H2O. Okay. If that is there, then we say that it is the washing soda. If it is not there, it is an anhydrous form. Then we say it is the soda ash. Okay. So the molecular weight of soda ash and washing soda will be same or different?
Different.
Will be different, no? Because there 10 water molecules molecular weight you have to add in washing soda. Here you don't have to add. This is sodium carbonate anhydrous. So when we treat this calcium sulfate with sodium carbonate, we will get the calcium carbonate. Calcium carbonate will precipitate or it will be soluble. Precipitate. Precipitate. It will come outside and you will get the sodium sulfate. So this is what kind of reaction? Double displacement, is it? They are exchanging. Can you say it is double displacement? Calcium carbonate, sodium sulfate, double displacement. So this calcium carbonate is the can be treated further. Okay. already it has come out as a precipitate. So if you treat, for example, this is the sulfate, this is sulfate form, but we also told that chloride form also may be there. So same reaction with chloride, calcium chloride with soda ash will give rise to calcium carbonate plus NaCl. Okay, that reaction will take. So ultimately, what is the point here? Here temporary by boiling can be removed. Here we will use the soda ash. Okay. If both this are there, that is bicarbonates are also there, chloride, sulfates, all are there, then generally people will use the zeolites. Zeolites are ion exchange resins. Okay, ion exchange resins. So mostly what we are using in the RO filter at home is the what? It is the ion exchange resin will be there in that one. Ion exchange resin. Okay. So what it will do, whatever the opposite charge is there, for example, calcium Ca2 plus, magnesium Mg2 plus. So in that there will be small beads will be there like this spherical shape. These are chemicals and they will have negative charge. So the negative charge is going to attract all these positive charge ions. Okay. So in this way that whatever the calcium part is there, it will take it. Okay. So it will exchange for already some ion that is there, which is a negatively charged. That will take place in ion exchange resin. Okay, so far it is clear. Any doubts you have in this chapter you want to ask?
No, sir.
Okay.